Доброго дня. Всім присутні, доброго дня. Ми розпочинаємо наше сьогоднішнє дійство. Сьогодні ми запросили на відкриту лекцію стосовно фантомних болей доктора Макса Джорджа Ortiz Catalán. Це професор, доктор філософії, і він є дуже досвідченим науковцем і керівником досліджень. Він був першим, хто створив імплантовані і неінвазивні медичні пристрої. Він їх впровадив від ідеї до клінічного впровадження. Все почалося ще в 2014 році. Наш лектор має великий досвід залучення, фінансування та формування команд високоосвічених і технічно кваліфікованих фахівців. Має в Україні 2 реабілітаційних центри, в яких впроваджуються його технології. В Києві це центр Титанові. Також він опублікував за своєю науковою роботою більше 100 наукових статей і більше ніж десяток співробітників, які отримали від нього поштовх для впровадження його технологій, тобто його, це я кажу про прямих учнів, які зараз вже є керівниками закладів. Також наш професор Ortiz Catalán, він керував розробкою першого взагалі протеза кінцівки, що інтегрується безпосередньо в кістку. Тобто це застосовується і приєднується, скажімо так, перша людина, якій вже імплантували цей новий нейром'язовий скелетний протез, він використовує вже цей протез понад 10 років. Тобто досвід застосування таких протезів вже дуже достатньо вагомий і довгий. Можна говорити, як то кажуть, не зупиняючись про нашого професора. Ми пропонуємо вам послухати його відкриту лекцію стосовно фантомних болей і застосування його технологій для зменшення таких фантомних болей. Дуже дякую. Прошу.
Can everybody see the screen? Yeah. Okay. So I will speak slowly, and if you don't understand something, you can raise your hand, and then Alina will translate.
Макс буде розмовляти дуже повільно. Якщо вам буде щось незрозуміло, попросіть мене перекласти, або там. Я дуже сподіваюся, що вам все буде понятно.
Аліна, може у вас сюди? Буде простіше.
So I do it in English. I do it in English. Okay. So I will talk about 2 topics: prosthetic limbs and phantom limb pain. And the first one is the prosthetic limb, and the challenge that we have is that we want to make an artificial replacement of a biological limb. When people think about prosthetics, they mostly think about the hardware. They talk about the motors and the batteries and the thing that you can see, which that would be the prosthesis. But that's only one part of the whole rehabilitation process. For the prosthesis to be useful, the patient needs to be able to control it. And if they want to control it well, it's useful to have some sensations. And then having a prosthesis that you can control, but it's too difficult to attach to the body, is not useful. So there's many patients who do not use the prosthesis because it's uncomfortable, it's painful, or they didn't have the rehabilitation that was needed to use it. In patients like Sweden, in places like Sweden, the state will give you a prosthesis. They will pay for it. So you don't have to pay, the state will give you an electric robotic prosthesis. And even if the state gives you a prosthesis, many patients don't use it. And the reason they don't use it is because it's not useful or it's very uncomfortable. So again, the prosthesis is not the only part. The rehabilitation and the attachment are very important. Because we have a lot of prostheses. You can buy these hands, for instance. They're a bit expensive, but they are available commercially. So the challenge is on how the prosthesis know what the patient is trying to do. We need to extract motor information from the nervous system, and we need to make sense of that information.
Всім все зрозуміло?
Так.
So one way of doing it is placing electrodes. So if I use my hand just at the wrist level, I can put electrodes on the skin, then I do movements. I get those signals into an artificial intelligence algorithm that learns what I'm trying to do, and then I can control every finger of the hand or do simultaneous movements. So moving closing the hand and flexing the wrist, rotating the wrist as well. Because we move in with simultaneous joints. Any engineer here?
Чи я тут інженер?
So, the engineering on how to do this, we made it free. It's open access since 2013. What you saw in the videos. The software, the hardware, it's been used a little bit all over the world. But the problem is that if you don't have enough information, AI cannot do miracles, right? So one way to improve it is that we can get information from the brain or the nerves or the muscles. We normally get them from the muscles. We can use electrodes or different sensors, and then you need electronics and algorithms. One way to improve the whole thing is looking at the sensors. And we know since the 70s that if you put an electrode inside the body, the signals are much better. You get access to more muscles, and you can also target the nerves. The reason you want to target the nerve is because, say, there's a mechanoreceptor in my thumb, and that goes up to my brain with the nerve. And if I put an electrode in that nerve and I stimulate the nerve, it doesn't matter if I do it here or here or here or here, my brain will create a sensation coming to wherever it was connected, so the thumb. So if I don't have a hand and I stimulate the nerve, the brain will think there's a sensation in space, in the phantom. But now the phantom is occupied by the prosthesis. So the patients feel that the sensation is coming directly from the prosthesis, because that's how the nervous system and the brain works.
Всім зрозуміло?
Коротенько так, трьома словами.
Може не так.
Що коли кінцівка ампутована, то у нас все одно є нерв, по якому ми відчуваємо будь-які відчуття, там гаряче, холодне. І навіть якщо кінцівки немає, якщо ми будемо стимулювати будь-якій частині цей нерв, він все одно буде мозок сприймати як роздражитель саме в цьому місці. І це буде цей фантомний біль. Ну не біль, а взагалі фантомні відчуття.
Який механізм з'єднання цього нерва, що залишився, штучним?
Може потім я розкажу.
Це пізніше буде.
Ну,
Зараз
питання...
тільки передіслов'я.
Преамбула, так.
Do you want to go? Is that a question? No question?
After.
So the problem is that if you put the electrode inside the body and the prosthesis is outside the body, you have the skin in between. And you cannot have just a cable going through the skin because it's not safe.
Проблема в шкірі, що вона йде як бар'єром передачі саме цих імпульсів, що є протез, нерв і є ще шкіра.
So this is one part of the human-machine interface. Another part of the interface is how you attach the prosthesis to the body. Normally, you use a socket. What is the word of a socket? Ukrainian?
Пунктоприймач.
Да.
So a socket puts a lot of pressure on the residual limb, and that can be very uncomfortable. So if you see here, there is the edge of the socket. There is redness on the limb. If you use it in the legs and it's not well fit, every time you walk, that's a bit of pistoning, and that over time has friction on the skin and can remove your skin. It can be very painful. So to have the prosthesis, you need to have this force on your body all the time, which patients don't like and cause a lot of problems.
Що люди після ампутації треба носити пуксоприймач, і це взагалі дуже незручно, і люди не люблять після ампутації його носити, тому що він незручний, пріє, натирає, і це приносить дискомфорт.
So an alternative to that is to put a titanium implant inside the bone, and then pieces stays inside the bone by something called osseointegration, meaning bone cells grow directly on the surface of the titanium. So it makes a strong mechanical connection, and then you can make an extension of the skeleton so you can attach the prosthesis.
Виходом із ситуації є остеоінтеграція, коли титановий цей штифт вкручується в кістку, і далі протез вже можна накручувати на нього. Правильно?
Так.
Може ви?
Ні.
So what we did is to combine these technologies. We have osseointegration for mechanical attachment, electrodes in the nerves, is the long one here, and muscles for control and provide sensations. And then we have the wire of the electrodes going inside the implant, and then we re-engineer the implant so it works as a gateway between the prosthesis and the body. So you can think about it as a USB port to the nervous system. So when the patient connects the prosthesis, they connect to the skeleton, but also to the nerves and muscles.
До цього штифта, правильно, буде під'єднаний, типу як...
В даному випадку самі електроди під'єднуються до м'язів із середини, не через шкіру. Тому сигнал проходить краще, і в цьому випадку через сам штифт, ніби як через USB під'єднується протез.
Який управляється сигналами
з м'язів.
I can work with almost everything. It's not feeling like a machine. It's more like my own art.
Кажеш, що це не відчувається як машина, а як
Because I
власна
like,
рука.
I don't feel handicapped.
Do you want to translate for me?
Yeah.
So that was the first patient we implanted in January 2013. So he has used that implant system on his daily life for 11 years now.
Це у 2013 році був перший пацієнт, якого запротезували таким чином.
So then we did an embedded system, electronics that we can put inside the prosthesis, so we can control the prosthesis, but also stimulate the nerves to provide sensations.
З таким способом протезування ми можемо повністю контролювати і нервові імпульси, які поступають до нашої голови.
І також є зворотній зв'язок, тому що може подразнюватись нерви в зворотньому зв'язку.
So there is a sensor in the thumb of the prosthesis. When the sensor touches the object, we stimulate the nerve. The patient feels there is a sensation and then it stops contracting so it doesn't crash the grade. So the electrodes, you can see the muscles contracting. It's contracting the muscles to close the hand. Then we stimulate when he feels there's an object. He told us there's an object on his hand. So while he's moving, he feels there's an object. And at the end, we just ask him to break the egg to show that it was a real egg. And you can see the muscles contracting there, and that's what the prosthesis is responding.
І саме через цей зворотній зв'язок протез надсилає про форму, вагу, і людина може відчувати, наприклад, у нього були закриті очі, що це дійсно настояще яйце, тобто він робив рухи, а протез відсилав нашу нервову систему відчуття від того, що тримає в руках. І видно, що там м'язи скорочувалися для того, щоб передавати ці сигнали. І навіть, щоб не здавити відчуття було, щоб настільки його тримати, те яйце, щоб не роздавити. Тобто протез це контролювати. Ну не протез, а саме ця система передачі імпульсу.
So this is of course, my background is in engineering and I work with surgeons. We have to work together to make all of this happen. And the patient could only open and close their hand, and we can do many more things. So one way to improve the system is having more electrodes or the electronics or the algorithms, but we realized that we could go back to the source and change the way the body is wired. So we take, say, in an amputation about the elbow, there is no reason for the biceps and triceps. They don't do anything. There is no elbow joint. So they don't have a biomechanical function. So what we can do is, say, the short head of the biceps the musculocutaneous innervation, you cut that, which is that one, so you cut it out. You take the ulnar nerve that allows you to do a strong close, and then you transfer that nerve to the head of the biceps. So when the patient thinks about closing the hand, the head of the biceps contracts. When the patient wants to flex the elbow, the long head of the biceps contracts. So now we have two signals, one for elbow flexion and one for closing the hand. And then you can do the same for the triceps, you get elbow extension and hand opening with the radial nerve.
Всі зрозуміли, чи
Так. I'm sorry, you mean patient must learning work with prosthesis?
The patient needs to remember how to close the hand because the nerve that, so there's the median nerve that closes these two fingers and there's the
Yes.
ulnar nerve that closes these two fingers. So that nerve is going nowhere because it's caught.
Yes, but
So then you change
how you understand where you can take its signal from different nerves?
Because we know what the nerve does. We know that the ulnar nerve does this. So the signals to close the hand come in the nerve, and then with the amputation they're closed. And we use the muscle as a biological amplifier. So when he wants to do this, signals come down in the nerve. They don't go to the hand anymore. Now we put them in the muscle. He wants to do this muscle contracts. And then we put the electrode there, and then we know the patient is trying to close the hand.
Yes, thank you.
So we have shown that this works for a few years in a few patients. The prosthesis, there is one button, the patients turn it on, they wear it, they turn it on, and then it works. They don't need to change anything. Because we're getting the signals from the muscles and the nerves that doesn't change. We stimulate the nerves that doesn't change. So the patients can do quite physically demanding jobs, and the prosthesis work equally well at minus 20 degrees or plus 40. This doesn't work with a normal prosthesis because if you have the electrode on the surface of the skin, it gets very cold, the skin gets dry, and then the signals are not picked up by the prosthesis. So one of our patients, he drives trailers in the north of Norway and Finland and Sweden. And if it's very cold and he's outside, the prosthesis didn't work. So you have to go inside the trailer, warm it up, go outside and try to do some work. That's a handicap because he couldn't work fully because his prosthesis wasn't working all the time. And that's why he was working 50% before. But now with implanted electrodes, the prosthesis works all the time, cold or warm. And so now he's working 100%.
В порівнянні з звичайними протезами, це ми просто включаємо, тобто є одна кнопка «включити і вимкнути», пацієнт його одягає, і на цьому все. І ще дуже великою перевагою є температура, тож звичайний протез, він як тільки холодно, шкіра перестає нормально передавати будь-які сигнали, і треба заходити в приміщення, нагріватися, і далі вже він може нормально функціонувати. А такий метод остеоінтеграції саме дозволяє людині нормально функціонувати. Тобто, наприклад, був пацієнт, який перебував в мінус, я не пам'ятаю, якщо чесно, дуже холодній атмосфері, тобто в країні холодній. І він міг працювати тільки 50% від своєї роботи. Але зараз з даною системою він може працювати повністю і повноцінно.
So we have worked with the medical anthropologists to look at the psychosocial effects of living with an implant inside your body all the time. And what we see is that they have more function, but their self-esteem is better. And they get involved in more activities of the daily life. Their work, their participation at work is higher, and as the patient said before, they see the prosthesis as part of themselves rather than an external object. Understood? Okay. So we'll move on. So that prosthesis can open and close and rotate or open and close and move the elbow, but again, it's not the same as everything we can do. So then we went back to the biological source, and then we say, okay, so the median nerve allows you to do this. So say, instead of taking all that nerve and putting it in a muscle, you take the nerve, you split the fascicles, the different bundles, and then you take one of them to innervate a muscle, and the other ones you take a free muscle graft from the leg, it's a piece of muscle from the leg, and you connect that to the nerve. And you do that with all the nerves. Then you put electrodes in the reinnervated muscles that are native and the free muscle grafts. And then when the patient tries to do movements, we get the signals out to the implant system, and then we run the AI to know what the patient is trying to do.
Це дуже тяжко.
Ми знаємо, які нерви передають сигнал для певних рухів, тому під'єднуємо електроди саме до них, якщо коротко.
Да, там можна зшивати, брати нерви from leg, yeah?
The free muscle grafts, yeah.
Можна брати нерви з ноги, і тобто пришивати, як іде нерв з біцепса, потім електрод, продовження трохи, яке взяли з іншого. І таким чином воно посилає сигнали, ця система посилає сигнали і може робити різні рухи, тобто там тільки мізинцями, тільки пальцями, тому що вони мають багато розвінчень, а не одне там чи два, на якийсь один рух.
So now the patient has an elbow that is power, a wrist that is power, and a hand that is open and closing. So here the patient is thinking about flexing the elbows, thinking about rotation of the hand, is thinking about open and closing. So it's a natural control. But more importantly, here the patient wants to flex and extend every finger, and what he's doing on his right hand. We pick that signals from the surgical reconstruction. That goes to the controller, and then the prosthesis does what he's trying to do. I think that's clear with the video. Okay.
Все зрозуміло.
So here you see in the prosthesis the thumb and the index finger are together, are independent, and then these three fingers we put them together. So this is what the patient is using at home on his daily life. So now, rehabilitation of amputees is not only the prosthesis. There's the rehab part of the therapies, but there's also a lot of surgical reconstruction that can be done. And the more surgical reconstruction, the longer the rehabilitation that they have to go with the therapist, because the patient has to remember on how to do those movements. We've done that in the below the elbow amputation, similar thing. The implants are a bit different. Here the patient, there's a sensor in the thumb and in the index finger, so the patient feels how soft or hard the object is.
Завдяки сенсорам передачам людина розуміє, наскільки м'яко чи сильно треба нажимати на будь-що, тобто силу стискання.
And then she's sorting them out from soft to hard.
І вона має поставити вечірьовість з самого легкого натискання до найтяжкішого, найсильнішого.
So the other part is on phantom limb pain. Phantom limb pain can be a bigger problem than an amputation. You know, if you have pain, you don't care about anything else. So I met many patients who tell me, I don't care about not having my arm or my leg. I want the pain to stop. Because when you're in pain, nothing else matters. So I think that's good. So post-amputation pain is divided in two primarily. It's actually three because neuroma, but pain in the residual limb and in the phantom. So wherever the patients feel it, it's what you call. And there are different reasons for it.
Все зрозуміло, що є два болі: фантомні і саме інкукс, правильно?
Ну, саме при пораненні, типу.
Да. І
It's very common. Most people with amputations will experience it. And this, as you can see, is common since the 80s and before. And that hasn't changed with the current treatments. The prevalence remains high. If you don't treat it, it becomes chronic, and then it's even harder to treat. And as I said before, pain demands attention. And because of that, there's documented impact on quality of life, employment, social relationships, and depression, anxiety is very common in these patients.
це статистика і те, що впливає взагалі цей фантомний біль в нашому житті. Це не так приємно, і емоціональний, депресивний, соціальний взагалі положення.
So there are many reasons in which you can experience pain. There are at least two. One is from the peripheral nerve, from nociceptors. How do you say nociceptor in Ukrainian?
Носорецептори так і буде.
Or central changes in the central nervous system, so maladaptive plasticity. For the peripheral problems, we now know there are some surgeries that can help with this. So we're running a large international clinical trial in North America with some American universities in Europe and Australia to see which of these treatments is more effective. They are all shown to be effective, but we don't know which one is better than others.
Вони тестували в дуже багатьох американських клініках, який саме метод оперування периферичних нервів буде більш вдалим і краще проводити сигнали. Ну, так.
So there are no surgeons here, or? No. Okay. So
But
if,
it is interesting.
okay, if you work with surgeons, so we have standardized the ways to do this surgery with surgeons around the world. So we made a video, step by step, showing how to do the surgery. We actually had a surgical course in Vinnytsia last week, where some of my surgeon friends came and they showed the local Ukrainian surgeons how to do these two procedures in patients, so they can continue doing it with their patients here.
Вони зробили такі от відеопротоколи, як повністю оперувати дані нерви. І ось, наприклад, на минулому тижні вони таким чином в Вінниці оперували. От, да, навчалися.
So, of course, if you have a prosthesis that you can control very well and you can feel with, these patients don't have phantom limb pain. But this is it's experimental procedure. There's not many. It's extremely expensive. Talking about $1 million probably if you consider everything that is involved. So it's very expensive and it's not so easy to implement. So it's not a solution for, say, all the patients around the world.
Протезування – це не є рішенням про фантомного болю прямо для всіх, тому що це дуже дорого. Тому треба мати якісь альтернативні методи позбавляння фантомного болю.
So I wanted to develop something that is easier to implement and more accessible for patients around the world. So we created this treatment in which we put electrodes on the surface of the skin. We have a standard computer screen and then a webcam. So the patients see themselves like in a mirror, and then we add virtual limb. We don't use the marker anymore, it's not necessary, but we put a virtual limb. And now the patients see themselves with an arm or a leg, but the difference with the mirror is that they can control that virtual limb in trying to control their phantom. Similarly than a prosthesis, they try to do movements, but then that happens in the virtual limb. Now prosthesis cannot do this or that, or do more complex movements. In a virtual limb, we can do all of that. So we can train the patients to do many more movements that you can with a prosthesis.
І вони придумали програму, для якої потрібен комп'ютер, електроди і веб-камера, щоб бачити, як в дзеркалі. Ці електроди щитують рух, а саме комп'ютер, такий як дзеркало, показує, який рух завдяки імпульсу, який він робить. І можна робити абсолютно все, а саме ця картинка буде показувати. Також вона повністю, це вже від мене, як я бачила. Так, вона повністю підганяється під картинку, тобто вона є продовженням і майже нічого, тобто людина це сприймає як свою кінцівку.
The purpose of this therapy is to have the patients to do a lot of phantom movements, is exercise, and we can increase the volume of exercise as we make them play games. So here the patient is controlling the car entirely with the phantom. He's moving his phantom hand, the car goes left or right. He's flexing the elbow, is accelerating. So everything that happens in the virtual environment is by the patient doing movements with their phantom.
Є багато різних програм. Тут, наприклад, людина вводить цю машину саме цією рукою, яка ампутована, тобто віртуально. Можете побачити, що там скорочується м'язи, і вона саме вводить, і таким чином це є гарна профілактика ампутованого.
So we done several clinical trials. One of the first one was in patients with intractable chronic pain. Chronic, they had pain for an average of 10 years. Intractable means that they tried everything else that was available in the hospital, and it didn't help them. So that's drugs, mirror therapy, implanted spinal cord stimulators, hypnosis, medical and non-medical options.
Люди пробували абсолютно всю, вони тестували цю програму на людях, які пробували все, і дзеркальну терапію, і...
Про наркотики не забудь. Про наркотики не забудь.
Медицину, медикаменти для зменшення болю, і ще вживлення
Стимуляторів в спинний мозок.
Стимулятори вколювання стимуляторів спинний мозок, і воно все одно не позбавляло.
І гіпноз там був теж. Гіпноз. Гіпноз також.
І гіпноз.
So what we saw is that in about 12 sessions, even though they have pain for about 10 years, in 12 sessions we got a reduction of pain of about 50%. Some patients more than others. And that reduction of pain stayed more or less for 6 months after the 12th session. And we were measuring pain before the treatment, because we know if you measure pain after the intervention is when the patients have the biggest effect, because you work with the patients, they got distracted, but we were interested in being more rigorous with these trials, so we were measuring before the session. So what you see here is the improvement from the previous session over time.
Взагалі ці люди відчували цей дискомфорт протягом 10 років, і коли вже після десь 20-ї сесії такої терапії, яку запропонував Макс, їм вони відчували вже полегшення. Хоча до цього теж воно було, як бачите, по діаграмі легше, але все одно могло повертатися. Але через 20 таких разів вже ставало краще відчуттям.
Something that is very important for these patients is that often they don't sleep well because they're sleeping and they have pain, so they wake up. So if you don't sleep well, your pain threshold goes down, and that means that it's easier for you to have pain, and then you don't sleep well, and then you have more pain, and it's a negative cycle. So what we saw is that
Саме велика проблема в тому, що такі люди відчувають біль під час сну, сон погіршується, і це як замкнуте коло. Людина, яка не досипає, відчуває біль більше, не досипає через це і ще більше, і воно як сніговий ком.
So the reduction of the pain interference was quite dramatic from the beginning, and as well as how much it affected their lives. So some patients don't want to drive a car because they're afraid that they're driving and then they have a lot of pain and then they can cause an accident. So the interference in activities of the daily living, which is the ADL, was reduced as well as the sleep.
Зараз. Для того, щоб людина відчувала в щоденних рутинах себе нормально, тому що навіть деякі не водили машину, тому що бояться, що попадуть в аварію через цей різкий біль, який відчують. І тому вони запровадили програму, де...
Якраз це якраз водіння машини.
Так, оці всі програми. Де на днівні рутини.
So because this system is relatively cheap and not so hard to use, we have implemented it in many countries. So we'll have to put the link here as well. So it's been used in a few hundred patients, and we've done a little bit of work on why it works. So we think that we basically are having the patients to use the same neurons that they were not using because they lost the link. And this can be a little bit complicated, so if you're interested in the neurology, you can read this article. It's open access, Frontiers in Neurology, or maybe it can be sent later to students. So that's all the theoretical background of what we're doing in there.
Кому буде цікаво, можна буде прочитати статтю про те, як змусити нерви, які ж не працюють, запрацювати знову після того, як кінцівку ампутували. Тобто заставити їх знову передавати ці сигнали.
So we also, if we want to have a better treatment, we want to train the sensory system as well. So we develop a system that allows to do sensory training. And that's some of the work that we've been doing in Ukraine. As you can see, here the patient is has a hand amputation, is controlling the virtual hand up there, and then a leg as well. And we have similar clinical outcomes. Now, the problem, one of the problems with war injuries is that they are very complex injuries. It's not only the amputation, there are burns, there are exposed fractures. So patients sometimes spend in hospital beds many months. And sometimes the rehabilitation is very poor. So during this time, they develop phantom limb pain, and we cannot use the system that we created because if the wound is not healed, we cannot place an electrode. Or if the skin is burned, we cannot place an electrode because we're not going to pick up information.
Великою проблемою є те, що крім просто якоїсь ампутації, зараз дуже багато є і інших причин, наприклад, згорівша шкіра, і через це ми не можемо цю технологію запроваджувати саме в них, тому що електроди не посилають сигнали на обгорівшій шкірі, і тому їм треба проходити багато місяців реабілітації, а тільки потім вже можна долучати цю програму.
So we develop a new treatment using now it's an app. It was before in the computer, so we don't use electrodes, and we guide the patients into doing exercises, and we have seen similar results as with the electrodes.
Це моє 10-те заняття вже. Десь після 3-го заняття одну таблетку на ніч приймав, потім після 5 заняття винахідник попробував зовсім з таблетки, винахідник, вроді спав більш-менш нормально. Це не дуже взагалі ніяких таблеток не приймають, важко.
So this patient has a very high amputation. It's almost a shoulder disarticulation. So we cannot place electrodes here neither because there's no residual need to put electrodes. He went through the treatment that I told you about in the app, and so his pain disappeared. But again, one of the important advantages of doing this is that if you stop medication, because medication tend to be addictive, and you basically hide when you are in opioids. So the quality of life is not great.
У нього була дуже висока ампутація, тобто прямо по плечі. І через це не могли нормально
There's no space, there's no
не
need to put
було
electrodes.
місця для того, щоб розташувати електрод. І ця програма, я так зрозуміла, що вона без електродів, це просто йде на стимуляцію мозку, що вона рухається, і він сприймає це як свою кінцівку, мозок теж сприймає як свою кінцівку в той час, коли програма рухає, і таким чином біль зменшився.
So we have
І далі він відмовився від медикаментів.
So we created another app to track pain because pain is difficult to measure. It's a personal experience, and we want to know what the effectiveness of these treatments is not only next week, but 2 years from now.
Вони хочуть зробити, ми вже зробили застосунок, в якому вони хочуть знати фідбек від пацієнтів, як вони гарно почуваються не тільки через місяць, а й через декілька років.
We use these systems with spinal cord injury. So there's a high spinal cord injury. As you can see, there is no movement on the hand. So there's a little bit of contractions in the residual limb. So we can use those contractions to drive what's happening in the virtual environment. And in this case, it's not an amputation. So what we do is we just cover the limb. We have the augmented reality there, so the patient see themselves with an arm, and they're controlling what's happening. What's happening with that hand. So we can use it for spinal cord injuries. We have used it for chronic stroke. So we published a clinical trial on rehabilitation after 1 year and a half after a stroke. So in a stroke, you get most of your rehabilitation in the first 6 months, and then it kind of flattens out. So these patients, after a year and a half, patients normally don't get any rehabilitation. And what we show is that we can get some, okay, I cannot play. So the patient is grabbing the ball and letting it go, which is something he was not able to do before the therapy.
Всі зрозуміли, да? Він не отримав нормальну реабілітацію, він каже, не міг нормально тримати м'ячик.
This is one patient that couldn't use her hand much. She had a stroke when she was 12. We met her when she was 15. She was 16, so it was 4 years after her stroke. We use similar technology with the electrodes to play games. So she become stronger, and now you can see now she has enough force to open the hand and be able to grasp it sufficiently to start using it. We have used it in the first double hand transplantation. So this patient received 2 hands that were transplanted. She couldn't move the phantoms. Her muscles were quite weak, so we trained her to use virtual reality before, so to control every finger. And the rehabilitation when she got her new hands was much faster. This is just a video of the function after the hand transplantation. You can see the tone is a little bit different. So this technology, we have one system with electrodes to drive games. We've seen that by guiding the patients to a training, personalized training, we can get a similar improvement. So it's been done for phantom limb pain. We have clinical outcomes with stroke, nerve injuries, spinal cords, as I said before, and arm replantations and transplantations.
Всім зрозуміло, так? Два різновиди, або електрод, або інвестиційка, яка рухається.
So I'm doing voluntary work as a research director at Prometei. It's a pain center in Vinnytsia. We mostly do pain. And then here at the Center for Complex Endoprosthetics, Osseointegration and Bionics, and Titanovi is kind of like the same. So there is more prosthetics and pain. And then also part of a charitable organization in Vinnytsia. Well, actually, now we work with everybody in Ukraine. So we help the students that lost their parents during the war to find the mentors so they can continue studying because they get some financial support. So if you know anybody that needs financial support to continue their education, you can reach out to us. I'm just launching an educational campaign on phantom limb pain. The reason is that many patients don't get treatment because they don't know what it is, and clinicians don't know what it is. In medical school, you don't learn. We don't learn about phantom limb pain. So there tends to be a little bit of ignorance, and how to do the treatments is not.
Проблема в тому, що багато хто ігнорує взагалі навчання цього фантомного болю, і саме через те не було нормального вирішення цієї проблеми.
So what we're doing is we have this educational campaign. It's a website where patients can go and learn about it, or clinicians can learn about treatments. It's science-based, and we try to keep it updated. And so this is happening now. We're going to have the site in Ukrainian soon. Right now it's only in English because my Ukrainian is not great, so I write in English and then somebody translates. So we if you want to help, you're welcome to.
Трошечки неправильно. Це саме для пацієнтів. Проблема навчання в школі, що там ніхто із пацієнтів не знав і не стикався з такою проблемою, і вони пояснюють на цьому сайті саме, що це таке, від чого він трапляється, пропонують рішення, І ось перечень, я так розумію, тих клінік, які допомагають. Зараз сайту немає на українських, але в плані далі вони перекладуть і зроблять українською.
Okay. So,
Запитання?
if you think about any questions, you can send me an email. There's some information on my website. And yeah, the 5PLP page is that one. So you can find it online. And now I can answer your
I
questions.
have a question about every each prosthesis is individual, every each patient, or that is total, for example, TASCA system?
No,
Or
so,
the-
so there is the prosthesis,
Yes.
and
as
it-
system.
and then it's how it's connected to the person. So the connection to the person, that is individual. So the socket, or where you put the electrodes, and how you train the patient, that part, it depends on the patient, but the prosthesis, they are standard.
But you prefer use a TASCA?
No, we don't care.
All
It doesn't matter.
What you can.
The patients can take a task and put an item and put something.
Another-
This doesn't change. The system knows what hand it is. So that if there are patients who like to do precise work or heavy duty work, they prefer these devices called a grafer. And that's very good because you can pick up fine objects and you know what it is. So it comes like this all the time. And they have like these little tips, so it lets you pick up smaller objects. So it depends, but he can take that out and put a hand and it will work the same.
I have some questions. First, it's what type of battery using in this prosthesis, and how patient can charge it?
Depends on the prosthesis. So most batteries are lithium. This depends on the prosthesis. That arm, I think you can see there.
Yeah.
You like take it off and put a new one.
Yeah.
So most patients yeah, it's like they come home and they go to sleep and they charge the batteries in the same way we charge your phone. So batteries is not a problem.
Okay. Next question. Do you have some research which focus on phantom pain, зниження, как правильно будет? How patients have low phantom pain with prosthesis or with AE computer training?
It's hard to do that research. So most patients, there's a correlation between the use of active prosthesis and low phantom limb pain. Not cosmetic prosthesis. It has to be an active prosthesis with electrodes. But what they can do with the prosthesis is not much. So they can control the fingers. They often cannot control the hand. So there are publications. There is research showing a correlation, but it's not very effective. Because the prosthesis cannot do much. So
Yeah, I understand. Because prosthesis is not a limb.
Yeah.
And one more question. You started in USA, yes?
No.
No?
Sweden.
Sweden?
In Sweden for many years, and then Australia.
I want to ask about who or what finance you used when you do this operation to patient. I mean three parts. First, it's making a prosthesis. Second part, it's osteointegrations, and third part, it's operation on nerves. Who financed it? Government or страховые компании?
No. So all that was research. So it was the government and foundations. So it was a research grant. But in Sweden, everything is paid by the government. So after the research money is done and we show it works, then the Swedish government pays for all of that. But that's Sweden. Like it's in Spain, they don't pay that, or France. So it changes depending on the country.
Because I understand, I saw on your picture USA, I understand that in USA very expensive make this operation because it's very expensive prosthesis.
So the operation is one thing, and then the prosthesis is a different cost. So that's why I was saying in the beginning that.
Всім зрозуміла дискусія.
Дискусія це просто
You
питання.
can,
Ой, вибачте, да.
you can buy different prostheses, so Tasca, Bionics, there are Asper, Autobox, so these can be bought separately. And then how you control them, you buy it from somebody else. And if you want to do a surgery, then you can do it with somebody else. So everything can be pick and match. There is not many places in the world that can do everything. We could do everything in Sweden, but now not anymore. Titanovi or the center in Kyiv, they can do everything.
And last questions, I'm sorry. I want to ask about safety of osteointegration because I understand skin we make a hole in a skin, and from this hole, which которая
Там провода идут из самого...
Да я понимаю, вот кожа, которая оборачивает сам остео...
Це остеоінтеграція, вона давно працює.
So there are two kind of implant systems. The Swedish system, the implant goes inside the bone, and then the percutaneous part goes through the skin here. And so the skin can go to the bone and seal with the bone, here, you see here. And then the bone seals with the implant with osseointegration. So you have a biological interface here, and the osseointegration interface here, which is also very strong. The other kind of implants is like this. This is a mechanical stop on the bone. So the skin does not see the bone, it cannot seal with the bone, so you have it completely open on the implant. So if you see a patient with this implant system, it doesn't look as nice as with this implant system because it's an open wound. The skin will not close here.
Yeah.
So there are risks of infections.
Yeah.
But in both cases, because osseointegration closes the path for bacteria, normally you don't have a superficial infection that tracks down the implant and it becomes a deep infection. So that's not very common. So there are often superficial infections that you treat superficially, and there's a small minority of deep bone infections. So in a study with this implant system, in 55 implants after 2 years, the patients had in average 1 superficial infection every other year that they treated with oral antibiotics. So the skin interface is not perfect. I personally think this one is better than that one. It looks better and biologically makes more sense, but the rate of infections are about the same. This can be improved, but it's not perfect, but it works.
Thank you.
Всім зрозуміло, бо це дуже цікаве було питання, що є два...
They understood, right?
Не перекладати?
Good. Any other question? Okay.
Yeah. How high is osteointegration? We have very high amputation now in Ukraine. And how high is this osteointegration?
You need to have at least 6-7 residual bone. So for a transhumeral, it'll be something like this. For the legs, you don't even see it, but you can still have a bit of.
And also, it's possible to do this osteointegration when we have some when we don't have some part of muscles higher than amputation.
So for osseointegration, you need bone.
Yeah.
So as long as you have the bone, you can do it.
But also we have connect with muscles and nervous.
Oh, so important point. Osseointegration and everything that's been done in Kyiv, there is 55 patients with osseointegration. One thing is osseointegration, the other thing is the implanted electrodes for control. And that's why I was, that's why I was saying that these things are separate, you know. Control and attachment, you can do them separately. So these patients have the attachment, but they don't have the implanted electrodes for control. Because it's not a product yet, it's very expensive, the company hasn't sorted it out, so we're trying to get it here, but it's taking time. Yes?
Okay, I have one question. It's regarding the fixation of the pin into the bone, and it's possible, with the patients who has osteoporosis.
Yes, but it takes longer. So when you've been an amputee for a very long time, you don't load the bone, and bone is living tissue, the bone will become weak. So you put the implant in, and then you slowly start. Have you ever broke something?
No.
So if you break an ankle, and when you start walking again, it's very painful. I broke mine twice. So you remove the thing and you start walking, and you still need aid because you're loading it and it's painful, and after a while, then it's okay. So it's the same thing here. You put the implant, and then patients, the way they do the rehabilitation actually is that they put a scale and they put some weight, and just a little bit of pain, and that pain becomes less over time, and then they can put all the weight in the limb. So it's possible, it just takes longer.
Дуже цікаво, тому що остеохлороз не є протипоказанням до такого виду протезистої інтеграції. Я, до речі, думаю, що неможливо. I thought that it's impossible.
No, it's possible. So the younger, the healthier, so smoking, which is popular in Ukraine, big no. It affects your cardiovascular system. If you're a smoker, your bones is not going to grow well on the implant. So smoking is a problem, so you shouldn't do that. The younger you are, the better. The sooner after the amputation, the better, because the bone is still stronger. But we have patients that are 70 years old with amputations after 20 years old. So it's possible, but it takes longer time.
І куріння дуже велика проблема для виживання такого, тому...
І алкоголь буде теж.
І алкоголь.
Ні, ну це я від себе.
Alcohol is okay.
А з зубами не працює. З зубами не працюють.
You didn't hear that from me. Other questions?
Я не буду позоритися, я через тебе запитаю.
Дуже гарно.
Добре. Чи є якась статистика успішності таких операцій в плані того, що остеоінтеграція окей, а самі сенсори відторгаються організмом? Чи буває таке?
Do you have any statistic about the successful, ще раз українською, бо я забула.
Остеоінтеграція окей, а іменно що самі сенсори відторгаються?
Osteointegration is okay, but sensors, our body doesn't lose it. Yeah, lose it. Do you have that the signal doesn't?
Ні, просто відторгається організмом. Гниють. Все.
So it's about the material, right? So here you have silicon, platinum, iridium, and primarily those are the ones that you can use. So it's the same materials you have with pacemakers and neurostimulators and so on. So and we have used them for many decades. So that there can be problems. So the more implant you have, the more material you have, higher the risk of infection. So if you have a lot of stuff inside, and the bacteria comes and makes a biofilm, then it's very hard to treat. And you have to take everything out. So the risk is not particularly for this system, it's in general how much hardware you have and how close. So you shouldn't do osseointegration if the patient is after an oncological patient just after cancer, if you don't know, you're entirely free. or if they have an ongoing infection, or they are prone to infections and so on, because that will probably create an infection on the implant or the rest of the other ones. So there is not many statistics because there are not that many patients. But again, the materials have been used for long time.
Thank you.
Якщо хоч там працює дуже велика команда під час такої операції, і навіть якщо там хоч якась бактерія, щось закрадається, все витягується, правильно? Все витягується і все помилує.
І в мене ще питання. Щодо апаратної частини, яка затримка сигналу? Я хочу повернути рукою, скільки секунд, мілісекунд, мікросекунд?
The question about the signal, how much time took the signal when I want to turn my hand, and how many seconds?
So the response time is less than 200 milliseconds. So it's fast enough for the patient. The patient don't feel any delay. But then it depends what hand you use, because there are some hands that are faster than others. So in virtual reality, for sure there is no delay. Once you have the hardware, you have some hands that are faster than others. So it's the speed at which we record and know what the patient is trying to do is much faster than what the hardware can do. So it depends on the hardware.
Thank you.
Всі зрозуміли, що все залежить від пацієнта, наскільки він гарно може посилати сигнали і поводитися своїм. Тому треба відчувати своє тіло всім і завжди.
Як реабілітолог, так.
Все? Більше питань не буде?
I want to say summary for our great group today and open lecture about. Thank you so much for your time, for your great work, for your heart, what you give for your patient and for us, for everybody. But you make great work for our country, for our patient, and for everybody. Thank you so much.
If you have any other questions later, you can write.
М.Київ.
Thank you.
Всім дякую.